let's talk about parallel and perpendicular lines. Parallel lines have the same slope but different intercepts. They lie in the same plane and they never intersect. Perpendicular lines also lie in the same plane, but they do intersect. They intersect in such a way that they form right angles at their intersection. In order to do that, they have to have opposite reciprocal slopes. In other words, the product of their slopes is -1. Let's look at examples of how to write equations of parallel and perpendicular lines. I want to write the equation of a line passing through the point 12, 5, and I want that line to be parallel to the graph of the line y equals 2/3 x minus 1. Well, because I'm talking about parallel lines, I'm going to use the same slope. So the slope of my new line has to be 2/3. Now, I have 3 different ways that I can write the equation of a line. I can write it in point-slope form. I can write it in slope-intercept form, or I can write it in standard form. We're going to look at all 3. First, point-slope form, because it's the easiest one to do. Since I'm going to go through the point 12, 5, and I already know my slope is 2/3, I can simply write y minus 5 equals 2/3 times x minus 12. That's the equation of my line that is parallel to the line with the slope 2/3, but goes through the point 12, 5. But if I want this in slope-intercept form, I need to find the intercept. The easiest way to do it is simply to rewrite my point-slope form in y equals mx plus b form. I can do that by distributing the 2/3. So I get y minus 5 equals 2/3 times x minus 8, because 2/3 times -12 is -8. Now I simply add 5 to both sides. So y equals 2/3 x minus 3. This is the equation of the line in slope-intercept, while this is the equation in point-slope. Now if I want to write it in standard form, the first thing I'm going to do is move my 3 so that I can get rid of my fraction. I do that simply by multiplying both sides of my equation by 3. So I get 3 times y minus 5 equals 3 times 2/3 times x minus 12. So on the left side, I distribute 3, and I get 3y minus 15. On the right side, 3 times 2/3 cancels, and now I distribute the 2, and I get 2x minus 24. Now I want to move the 2x to the left side of my equal sign, so I subtract it, and I get negative 2x plus 3y. And I want to move the negative 15 to the right side of my equal sign, so I add it, and I get negative 24 plus 15, which is negative 9. Finally, because I want standard form to be ax plus by equals c, and I want a to be a positive integer, I'm going to multiply my entire equation by -1 so that I can change my signs and a will become positive. Then I get 2x minus 3y equals 9. This is the equation in standard form, the equation in slope-intercept form, and the equation in point-slope form. All 3 of these are equations of the exact same line. Let's look at an example of writing the equation of a line perpendicular. So I want to write the equation of a line passing through the point 2, 4 and perpendicular to the line y equals 1/3 x minus 1. In order to write the equation of my new line, I need to find m. I know that m has to be the number that I can multiply 1/3 times to get -1, because the product of my slopes has to equal -1. So to solve for m, I multiply both sides of this equation by 3. So m equals -3. Now I want to write the equation of this line. I know that this is my new slope, and so I can use that to write my equation in point slope form. So I get y minus 4 equals -3 times x minus 2. Now if I wanted to write it in slope-intercept form, I can do a little bit of distribution. So I get y minus 4 equals -3x plus 6. Now I'm going to add 4 to both sides. So y equals -3x plus 10. And if I wanted it in standard form, I'm going to add 3x to both sides of the equal sign. 3x plus y equals 10. Now I have standard form, slope-intercept form, and point slope form of the same equation. So all three of these equations are equivalent to each other. They all will be perpendicular to the same line. So they will be perpendicular to the line y equals 1/3 x minus 1. And they will go through the point 2, 4. I have one more example for you. I want to determine if the graphs of these two lines are parallel, same slope, perpendicular, opposite reciprocal slopes, or the product of the slopes equals -1, or neither, which means it wouldn't satisfy either case. Let's take a look. In order to determine this, I need to have my equations written in slope-intercept form so that I have the slope of both lines. To find the slope of 4y equals -5x plus 12, I simply divide both sides of my equation by 4. This gives me y equals -5/4 times x plus 3. Now, the slope of this line, y equals mx plus b, m, we'll call that m2, is 4/5. And in this one, m1 is -5/4. I know that they're not parallel lines because the slopes are not the same. I want to test and see if they're perpendicular lines. So I'm going to multiply -5/4 times +4/5. And I want to know, will this equal -1? So when I multiply, I can first reduce. So this 5, I'll change colors to reduce. So that 5 cancels this 5, and this 4 cancels this 4, and I get -1 equals -1. That is a true statement. So these two lines are perpendicular. If they had the same slope, they would be parallel. And if these two lines, when I multiplied their slopes, did not equal -1, then they would be neither. If you didn't understand or didn't have time to take notes on any part of this video, you should use the pause and the replay buttons so that you fully understand the material before you move on.